All right, so first question, as always, is any questions from homework stuff?
This is the one that we were doing earlier, section 12.1 number 30.
So guys, this is 12.1, number 35. Oh yeah. All right, let me do one kind of like this. All right, read through that mess. It's sort of like reading legalese, right? The party and the second part, and individual number one, President Trump. There you go. So there's a whole section on the homework in 12.1, 31 through 40, whatever I assigned. They give you h of x, and they say find f and g so that when you put g into f, you get h. So this is backwards. Composition is when you put a function inside of another function. We are decomposing. If you look at this h function, can somebody tell me what the inside function is? What's inside? What function is inside something? 4x plus 7. And you see how g of x is the inside function. Do you see that? G of x then must be 4x plus 7. What is g of x in? What is it inside? What's it sitting inside of? I feel like I'm at the movies. What's going on? What is 4x plus 7 in? You told me it was inside. Okay, well, what's it inside? A root, a square root. So f of x must be the square root of something. I put this in, so this must be that. What do I get if I put this in there? Do I get this? Yes. So it's easiest to start with the inside function. So in the problem you're looking at, it would be like the bottom.
Oh.
That's the inside function. That's what g is, the inside. What is it inside of? The square root of something. So if you want to see another one, you steal with it there, sure. So if I add h of x equals 3 minus 1 over x to the 7th power, what's the inside function?
3 minus 1 over x.
Yeah. Okay, we gotta play with it. Nobody. A lot of other people aren't even looking. So yes, that is inside. So that's g of x. That's inside. What is that inside of? What's g of x? What is that inside of? Something to the 7th power. So that must be f. If I take this and I put it in here, I get this. So it's thinking backwards about that whole composition. It's like, what were f and g so that if I put one in the other one, I get this thing. I can see in your face, you're like, I don't get it at all, but I don't feel like asking anything, so. Okay. All right, anything else from homework stuff? No, okay. So, last time we did the section 12.1. Let's do a little review about how to find an inverse function. Real quick, anything raised to an even power, something squared, something to the 4th, what is it going to look like? X minus 1 squared, x plus 7 to the 4th. What they're going to look like here? What are they going to look like? Squared? X squared. What's x squared look like? Parabola. Parabola. I love it, right? any even power, dude, is going to look like this. It's going to be shifted around and all that kind of shit. It's going to have that shape. Why does that not have an inverse? What test do I use to see if it's invertible?
Vertical line and
Vertical line test just sees if it's a function. I know these are functions. Horizontal line test goes further and sees if it has an inverse. Does this pass the horizontal line test? No. So anything with an even power, why do they have to turn? Because if I raise a real number to an even power, I can't get negative, right? So they got to turn on themselves, which is the exact opposite of what I need to be able to find an inverse, based on yesterday's lecture, right? Odd powers, I don't know if you guys remember this, we looked at one of these. They look like a parabola where half of it fell out, because now it's allowed to be negative. So it doesn't turn. Does this pass the horizontal line test?
Yes.
Totally. So odd powers will have inverses, because they pass the horizontal line test. They're what's called 1-to-1.
So if it's an even power, you just write no solution?
Well, no. You can do something. Here's what's funny. If I have a parabola, like this guy, let's make one more specific. Do you see the problem is it repeats itself? Well, what if I say x has to be at least 0? Does that pass the horizontal line test now? Yeah, so if you restrict your domain, then maybe you make it so that it doesn't go back on itself, right? So you'll see in some of these problems they say this. That's why. Because now this is invertible. In fact, the inverse, if I have x squared, what do you think the inverse is? What's the opposite of squaring something? Square rooting something. The reason that's not generally true is that a square root doesn't have a negative part. But now look what I did by doing this. I took that negative part away. And you see how these do exactly what we expect. They are symmetric right there. There's the mirror right there. But you have to restrict the domain to take away that repetitive part, that turning on itself piece. If any of you go into pre-calculus, get into trigonometry, that's where you see the oscilloscope, the sine waves, and we've seen some of those before. That has a lot, this really doesn't pass. But if I restrict it to be there, now it passes. So that's going to become an issue about finding the inverse of those funky repeating functions. You have to really restrict the domain so that it doesn't go back on itself. Okay, that's a little bit beyond what we need to worry about. Okay. So coming back to this dude, what are the steps to find the inverse?
Make f of x.
I got to bring y back, right? Bring a y back.
But it's not a step, though. You said it's just like a...
No, this is a step. F of x is y. All good. The next thing is not an algebraic step. What do I do next?
You switch the y.
Yeah. Right? And we saw this. We saw this visually, just the idea that it undoes what was being done so the domain arranged change places. We saw it a few different ways. Thank God, algebraically the same thing. So if I give you a graph, how do you graph the inverse? Switch all the x and y points and graph those. Okay, algebraically, what do you do? Same thing. You switch x and y. And then what do I do? Solve for y. The shit is happening next door. Now it's these guys. God, I got this person straight. In the process of solving for y, do you see how I'm going to undo all the operations? I'm going to do the opposite operations. And that's what an inverse is. So what would I do first to try to solve for y?
Add 1.
No. I can't do that because where's all this stuck in?
Oh.
Got to get rid of this thing because it's all stuck in there. What do I do to kill the fifth power? Take a fifth root. Die. And then of course, now I add 1. And then I divide by 2. So I get F inverse is all this business. Let's trying to be a fifth root. Oh well, it's a Superman root. I don't know what the hell's going on. 5. Okay. So what's this guy do? It doubles it, takes 1 away, fifth power. This cuts it in half, adds 1 fifth root. It's composed of all the opposite shit this guy had. So it is the inverse of this guy. It's beautiful. Okay. Okay. I love you. You guys. I never get used to that. No reaction at all. All right. Okay, so we're going to get into the next section. I desperately need to get into 12.3 and 12.4, and we'll see if I can do that today. 12.2 is next. This is going to be a very strange question, but there's one place we haven't put x yet, for sure. Don't overthink. We've seen functions where the x is on the bottom. Obviously, we've seen functions where the x is being raised to a power. We've seen square roots of x's. We've seen x's being, with other stuff being raised to a power. We've seen x a ton of places. One place we haven't worked with yet is where x is the power, right? For example, like that. Now, what's another name for power? What is it called in the order operations? Exponents. That's why it's an E, is why you excuse, right? If we call it power, then please permit my, I don't know. So this is called officially an exponential function. Because the power is where the variable is. So it's called an exponential function. They're having a freaking party over next door. Too bad you guys took me. Math guys, we don't like to party. How do you think you would graph this thing? You know what to do. You know what to do. How do you graph anything when you have no idea what it looks like? You make a table, right? Every value you plug in, you know how to do it. What kind of values will you plug in? When there's something I hit that I have no idea what it looks like, I always use these 5 to start with. -2, -1, 0, 1, 2. You definitely want to use 0, you definitely want to use negatives, and then of course you want to use some positives. Because functions might do different weird things with all those types of inputs. This might not be enough. So try it. Try to finish this table out. Just make sure everybody's on the right track. We'll put a -2 in. 2 to the -2, right? What's 2 to the -2? What's negative power do? Flip it. And what's 2 squared? Okay, so there's 1 done for you. Finish the rest of it out and try to graph it. Oh, here it is. If you look on page 237 in the Green Book, they have the same function. They have a little graph sitting next to it for you to use if you want to do it there. Thanks, Gary. Oh, yeah. Nice job. You do it, buddy. All right, don't worry about their stupid thing here. Let's see. So when I put a negative 2 in, there's negative 2, I get a 1/4 out. When I put a negative 1 in, what do I get?
1 over 2.
Yeah, 2 to the negative 1 is 1/2, 11. When I put a 0 in,
1.
well, I get 1, become a 1. When I put 1 in,
You get 2.
that's crazy. When I put a 2 in, no way. Okay. So if we plot those points, 0, 1, 1, 2, 2, 4, negative 1, 1/2, negative 2, 1/4. Now here's the interesting question. What is 2 to the negative 3? It would be 1 over 2 cubed, 1 over 8. So 1 over 8 would be half as close to the x-axis. What's 2 to the negative 10th power? 1 over 2 to the 10th. Is that 0? 2 to the negative anything is 1 over 2 to the that thing. You guys with me? What's 2 to the negative 100th power? 1 over 2 to the 100th power. Do you guys understand that's very small? 1 divided by 2 to the 100th is stupid small. It's really close to 0, but is it 0? No. As a human, I would say it's freaking 0, but it's not 0, right? So this is what's really weird happening back here. It's just getting closer and closer, but never touches the x-axis. There's no way I can raise 2 to a power and make it become 0. You guys with me? 2 to the negative 3 trillion is 1 over 2 to the trillion. 3 trillion, whatever it is. It's going to have a 1 on top. It's not going to be 0. What do you call that when you have something get really close but not quite get there? I can't remember if I used this word yet this semester. It's called an asshole. No, an asymptote. Yes. Sounds like a horrible math insult. So if I connect these up, this side is just going to get stupid big. 2 to the 6th power, it's not stupid big yet, 64. 2 to the 10th power, I don't even know. What is that? 900 or something. So it's going to get stupid big. Anybody watch any horror movies? You know, like The Blob and stuff, or even like Virus, and they say it's growing exponentially. Oh, exponentially. Oh, womp, right? So whenever you hear that, it's growing exponentially, or the virus is spreading exponentially. Tomorrow in New York City, the next day the world. Oh shit, what do we do? Right? Yes. that was me going to ask. Now back here it's going to shrink and shrink and shrink and never quite get to the x-axis. Let me tell you something really kind of silly. It's not really silly, but there's something called Zeno's paradox. Has anybody ever heard of Zeno's paradox? No. Here's the paradox. Zeno wants to go to the next town, but he's never going to make it. Because in order to get to the next town, he has to go halfway. And then he has to go half of the remaining distance. And then he has to go half of the remaining distance. And then he has to go half of the remaining distance. And then he has to go half of the remaining distance. If you keep cutting it in half, will you ever get there? No. You're always a distance away. Go half, go half, go half. You're never going to get there. When my teacher first told us this, I'm like, tell the dude it's twice as far away as it really is. Let him freaking, he's like, oh. But you guys, that's exactly what's happening here. It's getting half as big, half as big, half as big, half as big. It's never going to make it to the x-axis. So that's an asymptote right there. We represent that with a dotted line. Asymptote. So every exponential, everything that's a number to it, the x power, is going to have this shape. Am I doing it right for you guys? Yes. I'm trying to do it for you guys. Yes.
So why 2 to the 0 is 1?
Yes.
Why?
Why? All right. Do you guys remember? How do I get x to the 0? If I put x squared on top, what would I put on the bottom to make it a 0 power? Because what do you, yeah, 2. Because what do you do with powers when you divide like bases? You subtract. And what is something divided by itself? Okay. All right. Also, what is the only number I can multiply this by so that it stays the same? What's the only number that I multiply this by and it stays the same? 1. 1's the only number that can make something stay the same. And what happens when I multiply this by x to the 0? What do you do with the powers? Add them. 0 plus 8 is? It stayed the same, so x to the 0 has to be 1. Because 1 is the only number that you can multiply by and keep something the same. There's 2 different proofs that we talked about earlier this semester about why something to the 0 power is 1. Little bugs? Yeah. I don't know what the hell happened in this room, but oh well.
There's not even an imaginary number or a complex number that'll make an asymptote.
Now that's a neat question. Now that you know about complex numbers, every time we learn something new, we don't have the time in this class to really investigate what if you start putting complex numbers in. But there's a whole other side to this. It's this, and that's, remember the video? If you were here that day and the dude picked it up and they got all colorful and other things were happening, you could do that with any graph you make in an XY plane. It's missing all the complex stuff. So complex numbers, when you bring it into here, you can have all kinds of shit happen. You with me? Okay. There's a whole series of classes, upper level mathematics, that's called complex analysis. You kind of go back in time and say, what if this was complex? What would happen? And it gets freaky as shit. But yes, if you brought complex numbers into this, that would change a lot of what's possible. I like it. But you start to think about what the hell 2 to the I would be. That gets, let's not think about it. I like it, but you can look into it if you want to. It's kind of nifty. All right, now let's focus with real numbers. What's the domain of this? Yeah, it's going to go forever back, and it's going to go forever. I can do 2 to the 18 million. I can do 2 to any power I want to. So the domain is going to be all real numbers or negative infinity to infinity, right? There's no restrictions on this. What kind of number can I not raise to 2? I can raise it to anything I want to. But what's the range of this? Is there a ceiling? No. So it's going to go to infinity. But what's the floor? What's the floor? What can I not go below? 0. Does it include 0? Does it ever get to 0? Thank God most of you guys are shaking your head no, because that's what this whole thing was all about here. It never gets to 0. So the range is 0 to infinity, not including 0. The domain is going to be all real numbers. I can put anything I want to in there. Okay. Yes?
If you're not including the 0, you can stop by 0.
Yeah, definitely. Right? What part of what I just wrote says I don't include it? It's a parenthesis, not a bracket. Right? Why do I have to do that? Why wouldn't you put 1? If you put 1, you just excluded an infinite number of things. What about 0.1? If you put 0.1, you excluded an infinite number. What about 0.01? What about 0.00001? And you're like, all right, Jeff, I get your freaking point. So this is the only way we can represent everything above 0. Because what number is right next to 0? I don't know. Shit. So we just do this. Right? Okay, maybe. Maybe. Does it pass the vertical line test? Of course it does. Does it pass the horizontal line test? It does, totally. Yeah, this keeps going down, and this keeps going up. So every horizontal line will go through only once. Therefore, this guy has an inverse. I like it. In fact, I could graph that inverse on this graph. Don't I have a series of points here? What points would the inverse function go through?
1, 0.
Yeah, 1, 0.
2, 1.
2, 1.
4, 2.
You guys finish it out and graph it. Graph the inverse. We're going to graph the inverse function before we even know what the shit the inverse function is. Because we're insane. see, it's going to go through 4, 2. It's going to go through 1/2, -1. It's going to go through 1/4, -2. So if you forgot, you just switch the x and y to see what the inverse is doing. I kind of know already what it's going to look like. It should be over here like this, right? It's the mirror image of this across the y equals x line. Let's see, 1, 0, 2, 1, 4, 2, 1/2, -1, 1/4, -2. Where does it look like there's an asymptote now for the inverse? If you look at this, yeah, the y-axis, I kick ass. So it's the x-axis for the function, and what do we do to find the inverse? We switch x and y. So if the function has an x-axis asymptote, the inverse is going to have a y-axis asymptote, because we switch x and y. Bless you. How you guys doing? You all right? Okay. You all look very impressed, but I'm a math teacher. I'm used to that. So there's an asymptote here now. Right here, there's an asymptote. It never gets to the y-axis. So here's what's kind of nifty. What's the domain of this one? What's the smallest x I can almost use? Going to use -1x for this graph here. No, because here's an asymptote right there. So it goes from 0 to infinity. What's the range? Do I not get it? There are outputs I don't get. This keeps going up and up and up and up and up. This keeps going down, 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 down. So what's the range? Yeah, -infinity. Now remind me, look at me. How do you find the inverse? Take x and y and you switch it. Domain is related to x's. Range is related to y's. So here's the function, the domain and the range. If I flip those, that's what the inverse does. Does that make sense? Everything x and y flips for the inverse. That kicks so much ass. If you know the domain and range of the function, then you know the domain and range of the inverse. You just switch them. Because all the x's and y's switch. Let that make sense. You gotta love that everything related to inverse just goes back to switching x and y. Okay? So we still have to give this function a name. It's a function. It exists. It's got to get its own name. Sort of like, what's the inverse of cube rooting something? Cubing something. So they both get their own symbol. They get their own name. This poor dude, we got a picture of it, but we don't even know what its name is, right? Okay, so let me let you guys... Oh, what did I want to do? Oh, real quick. Look at this here. Do you guys remember what this would do? The -3, what it would do to the picture? Shift it where? I love all that. Is that -3 with the x? Is it up there with the x? No, so it's not going to be left and right. It's going to be up or down. So if I do whatever 2 to the x is, this is going to take that down 3. Kick ass. So 2 to the x was this. There's 2 to the x. -3 would take every point 1, 2, 3. 1, 2, 3.
What page is that on?
1, 2, 3. I'll tell you in a minute. And the asymptote was at 0, so now the asymptote is at -3 because everything goes down 3. Jeff, stop looking at that. It's hard to do it up there. So, I mean, this is the idea of this is page 239. It's a calculator activity, but I said screw it. This is the idea that no matter what the function is, if I put -3 next to it, it's just going to pick it up and move it down 3. That kicks so much ass. Right. So, here's what I want you guys to work on now. I think it's the other side of that. Which one? The one that had the composition and inverse on one side? Yes. So does everybody have that? On one side it says Math 108 composition and inverse practice. On the other side it says exponentials and logarithms. I need you to work on that exponential logarithm side. So I need you to look at this side here. Oh, you want? You got this one. A lot of reading, but oh well. At least you can have some time away from me speaking. Go ahead and try to read through this. I'll come back and explain some of this, but I want you to try to get it yourself first.